We learned about the quadratic formula. It was very exciting. I hope you remember it. You can also remember the song if you choose to. I think, in fact, if you go through if you just type into YouTube the quadratic formula, I bet you get all kinds of different songs. Well, probably put in quadratic formula song, and you'll find all kinds of them. Anyway, this leads us to this thing that's called the discriminant. Okay, and why we use it. So let's revise. Let's review. Here is our beautiful quadratic formula, right? We solved this equation for x for really any quadratic equation out there. Okay, we just know what a, b, and c are, and we substitute them in to use them. And what we're going to do is we're going to use this the formula here, and we're going to take a look at primarily that part that's underneath the radical, and that is what's called the discriminant. Okay, and as we move through this, we're going to start talking about how this can help us determine some of the problems, right? So let's go ahead and let's just start going. Let's just get right into this, okay? So here we have a quadratic formula, okay? And what I like to typically do is spend about 10 to 15 seconds trying to factor it if I can. If I can't, then I'll just go right into the quadratic formula. Okay. Now this one I'm just going to use the quadratic formula. So we're just going to go ahead and just start blasting through this. Okay. So negative b plus or minus the square root of b squared minus 4ac all over 2a. Now when you first start doing this, it's pretty helpful to take a, identify b as -2, and then we'll identify c as -3. Okay, and so what I'm going to do here is I'm going to then plug them in. Okay, so again, when you first start doing this, it's a good idea to identify each of them so that you get sort of used to it. All right, so x is equal to negative. I like to put the negative and then I plug in b, especially in cases like this when you have a -2, because we're taking the -2, plus or minus the square root of b squared. Now, because I'm squaring it, it doesn't really matter. I'm going to do -2 squared. It doesn't, I mean, if you forget the negative there, it's not going to be a huge deal. Minus 4 times a, which is 1, times c, which is -3. Okay, and I'm going to plug this in. And we're going to do all of this over 2 times 1. Okay, well, I'm going to do a whole bunch of evaluating right here. So I'm going to do -2 is +2, and that's going to be plus or minus the square root of, okay, so this is 4 squared, or 2 squared is 4, minus 4 times 1 times -3, so that's going to be actually plus 12 all over 2. So I'm going to get x is equal to 2 plus or minus, well, 4 plus 12 is 16, and the square root of 16 is 4. Okay, and this all over 2. So then that's going to give us that x is equal to, okay, let's do 2 plus 4. So 2, or let's do the -1. 2 minus 4 is -2. -2 divided by 2 is -1. Or, okay, I'm going to plug positive. We'll do the positive of 2 plus 4 is 6. 6 divided by 2 is 3. So we know that x is equal to -1 or 3. And really what we're doing here is we're saying when this is when y is equal to 0, right? So if y is equal to 0, and x is -1 or 3, well, really what this means is that when x is -1, y will be 0. And when 3 is, or x is equal to 3, y will be equal to 0 also. So if we were to look at this and we were going to graph it, I'm going to clear this out here for a second, okay? So I'm going to clear this. If I were to graph this, okay, it would look something like this. Uh-oh. Let's see. Oh, well, let's see. How can I do this real quick? Oh, here we go. Reset the page. Now, if I were to graph this, it's going to look like that. Okay, and notice where these points are. Okay, so I've got a point here and a point here, and look, this happens to be -1, 0, and this one happens to be 3, 0. Okay, and then my line of symmetry is at +1, right? And so if I were to do -b over 2a, right, when x is equal to -b over 2a, x would be equal to -2 times 2 times 1, so that's x is equal to 1, right, which is my line of symmetry. Plug it back in, find my vertex, and move on from there. Okay, so hopefully I'm hoping things are kind of clicking in your brain. You're starting to see things. So you're sort of looking at it and going, oh, whoa, all right, I got this. So let's try another one. Let's take a look at this one. Why don't you go ahead, you pause the video, and you try to find what x is equal to using the quadratic formula. Go. All right, so let's go through this. If I set this thing equal to 0, it's going to be x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. A is equal to 1, b is equal to negative 4, c is equal to positive 7. Okay, so x is equal to negative 4 plus or minus the square root of negative 4 squared minus 4 times 1 times 7 all over 2 times 1. X is equal to positive 4 plus or minus radical 16 minus 28 all over 2. X is equal to 4 plus or minus the square root of negative 12. Whoa, wait a second. Wait a second. Looks like I'm going to end up with, how can I do that? Radical negative 12, right? So let's see, 4 plus or minus any perfect squares in there. Yep, 4 comes out of there. So 2i radical 3, right? Because radical negative 12 is equal to, we'll say, radical negative 1 times 4 times 3, right? So this is equal to, this becomes I, and 4 becomes 2, and then the radical 3 is still in there, okay? All over 2, so then I can divide by 2. Everything has a factor of 2, so I could say x is equal to 2 plus or minus I radical 3, okay? Awesome. But that's not a real number. That's an imaginary number, right? It's a complex number with an imaginary part. That's not going to work. In fact, if I were to try to graph this, what would that look like? So let's go ahead and find the vertex, okay? And go ahead. Why don't you find the vertex now? Okay. Hopefully, you were looking at this, and I'm going to get rid of this real quick. So we're going to go, and it's a little dark. Let me change it for you. Ah, that's much nicer. All right, so hopefully you decided to do x equals negative b all over 2a, and so x is going to be negative positive 4 over 2, so x is equal to 2. Plug in 2, so you get 4 minus 4 times 2 is 8 plus 7, so we got 11 minus 8 is 3. Okay, so 2 comma 3 is the vertex. I already graphed this, so let's see what it looks like. Hey, look, 2 comma 3, 2 comma 3, right? And then I move up. Well, if you notice, this thing never crosses the x-axis, right? And this x-axis is where y is equal to 0. Okay, that's this line here, this one. Okay, all the way across. So this parabola, right? It starts on my vertex here, and it opens up. It will never actually touch the y-axis, which is why you end up with imaginary or complex answers there. Okay, there's no real number solution for this. Okay, and so what's the point of using the discriminant, right? Why are we going to actually use that thing? What is the point of it? So what does that help you find? So why don't you go ahead and think about that. I want you to look back maybe at the problems we just did and say, what is it about that b squared minus 4ac part? Why would we use that? What would that help us do? Okay. And in the process, what I'd like you to do is go ahead and try graphing x squared minus 4x plus 9. Okay, and I want you to think about how many solutions could there be here, right? How many solutions do you think are going to show up for this one? And when I say solutions, I mean how many times will it cross, right, the y-axis? Here we had it crossed, here, let me lighten this one up too. Okay, here this one crossed, whoops, this one crossed, right, at 2 different locations. Okay, This one we had crossed at 0 locations. Right, so then why don't you try this one? Use the quadratic formula to find your x's, and then let's bring those ideas to class.